All right, so in this section, we're going to talk about how we measure the center of a quantitative distribution and three statistics that come from that. So there are three ways to measure the center of a data set. We have the mean, median, and mode. To find our mean, first, again, the mean is the average of the data values. So to find it, we add all the values in the data set and then divide by however many data points we have. It's interpretation. So if I ask you to say what it means in context, it's just the average. The median is the midpoint of the distribution. So again, this is the exact middle or midpoint. To find this, you're going to start by ordering all of your data points from least to greatest. If the number of observations n is odd, so for example, if you have 7 data points, the median is the exact center. If the number of observations is even, then the median is the average of the two center. And the interpretation is that half of the data points fall below the median, half fall above it. The mode is the most frequently occurring data value. A distribution may have no mode, one mode, which is unimodal, two modes bimodal, or multiple modes, which is multimodal. We talked about that when we talked about describing the modality of a distribution. And again, its interpretation is it's the most frequent value. So if I want to start by finding the mean, median, and mode of these data sets, I want to start by first arranging these data values in order. So I'm going to go ahead and start there. So I'm going to start with my 10, and then I'm going to go to 25. And then we got 38, 39, 39, 71, 76. To find the mean and the mode, you don't necessarily need to rearrange, but again, the median, we do have to rearrange. So I like to do it to start off. So to find the mean of these data points, I'm going to add up all of these values. So 10 plus 25 plus 38 plus 39 plus 39 plus 71 plus 76. And I'm going to divide that by my number of data points. There are 7 here. That gets me 7. So I can add all this up. Plus 39 plus 39 plus 71 plus 76. So that's going to give me 298 divided by 7, which gets me an approximate mean of 42.57. My median, again, my median is my midpoint, again, the exact middle. So since I have an odd number of data points, I'm just going to go to the exact middle. The exact middle here is 39 because it's 3 to the left, 3 to the right. So I have 39 as my median. And then my mode is my most occurring data value. And the one that occurs the most is 39. So that's how you find those statistics from the data points. Okay, we can go ahead and do the next one. Same exact thing. If you want to pause it and try it, you can. I'm just going to go ahead and do it. So I want to, again, order these from least to greatest. So I'm going to start with 9. And then I have 40. And then I have 42. 50. I have 61. 63, 79, 80, 95, and then 109. Okay. All right, so again, to find my mean, I'm just going to go ahead and add all of those up. So I'm not going to show the adding. So 9 plus 40 plus 42 plus 50 plus 61 plus 63 plus 79 plus 80 plus 95 plus 109. When I add that, that gets me 628. So 628. And then I'm going to divide that by my number of data points, which is 10. So 628 divided by 10 gets me a mean of 62.8. Now for my median, since I have 10 data points, I need to go to the middle 2 data values. So my middle 2 here are 61 and 63. So I'm going to take the average between those two numbers. So to find that, I'm going to do 61 plus 63 and divide that by 2. So that gets me 124 over 2, which gets me a median of 62. And then my mode is, again, the most frequently occurring. Seeing as I have no repeats with these data values, there is no mode. All right, so again, that's how you find the mean, median, mode just given raw data. So for this example, the mean weight of 5 complete computer stations is 167.2 pounds. The weights of 4 of the computer stations are 158.4 pounds, 162.8 pounds, 165 pounds, and 178.2 pounds. What is the weight of the 5th computer station? So again, remember what I did for my mean. The formula is that the mean is equal to the sum of all the data divided by my n, and then remember n is the number of data points. So if I want to set this up, I know my mean value. If I just kind of plug it into that formula, I have that my mean is 167.2. So I'm going to start there. So 167.2 is now equal to all of the 5 added together. So I know 4 of them, 158.4 plus 162.8 plus 165 plus 178.2. And I don't know that 5th one, so that's what I'm going to call my variable x. And I'm going to divide that by the number of data points. So it says 5 computer stations, so this is going to be divided by 5. And now we're just going to go ahead and solve this, okay? So I'm going to go ahead and add all those up together just to make my fraction a little shorter. Okay, 158.4 plus 162.8. So this gives me 664.4 plus x divided by 5. So now remember, we have this fraction. In order to get rid of a fraction, you're going to multiply both sides by the denominator. So I'm going to go ahead and multiply both sides by 5. That cancels that out. And I'm going to multiply that 167.2 by 5. So that gets me 836. So I get 836 equals 664.4 plus x. And then just to get that x alone, I'm going to subtract that 664.4. So that gets me a weight of 171.6. So the weight of that last computer station is 171.6 pounds. Okay. Next up, outliers and measures of center. So the median and mode are resistant to outliers, meaning that they are not going to be heavily impacted. So if you have an outlier, those two statistics won't change. The mean is non-resistant, meaning that if there is an outlier, it is going to be heavily impacted. Okay. So the scores of a recent quiz in Algebra 2 are listed there. So we're going to start by finding the mean, median, and mode. So again, we're going to go ahead and list all these in order. So I'm going to start, I got 50, and then there's a 55, then there's a 60, and then we got 65, 70, 75, 80, 90, 95, and then 2 100s. Okay. All right, so to start to find that mean, I'm going to go ahead and add everything together. Plus 55 plus 60, 65 plus 70, plus 75 plus 80, plus 90 plus 95, plus 100 plus 100. So that gets me, adding all those scores together, that gets me 840. And I'm going to go ahead then and divide by my number of data points, which is 10. So that gets me then a mean, or 11. Oops, sorry. 11 data points. So 840 divided by 11. So that gets me an approximate mean of 76.36. My median. So since I have an odd number, I have 11 data points, I can go to my exact middle. So my exact middle here is 75. And then my mode, my most frequently occurring score, is 100. Now it says a score was accidentally forgotten, a 10. With this, find the new mean, median, and mode. Okay, so if I were to go ahead and just tack on a 10 there. And I want to go ahead, I'm going to start with my mean. So you don't have to re-add everything because you already got 840, so we're just going to add 10 to that. So 840 plus this new score of 10, but we're not dividing by 2 now. We're still dividing by how many data points we have, which is 12. So that's going to get me 850 divided by 12, which is about 70.83. Okay. My median. So since I now have an even number of data points, I need to look at my middle two values. So my middle two values here are going to now be 70 and 75 because that's going to be 5 over to the left and 5 over to the right. So I'm going to find the average of those two numbers. So 70 plus 75 divided by 2, which gets me 145. 145 divided by 2. Which gets me a median of 72.5. But my mode still has not changed. My mode is still at 100. So now, describing what happens to these statistics. So I added this outlier. If we take a look, the mean dropped by about 5.5 points, but the median only dropped by about 2.5, and the mode didn't change at all. So remember, adding this outlier, it is going to change the mean significantly. So if it's a low outlier, it's going to pull the mean down. If it's a high outlier, it's going to pull that mean up. So again, in our case, we have that the mean changed significantly. Because of the low outlier. Okay. The median did not change a lot. And the mode did not change at all. Okay. And remember, the reason why is because the median and mode are resistant to outliers. Meaning that if I have an outliers, these statistics will not be impacted too much. The mean will always change whenever you have a lower or high outlier. Okay. Next one, we have the dot plot, shows the distribution of goals scored by the U.S. women's soccer team in 2016. Find the mean and median and interpret these. Okay. So we want to start, if we find our sample size, if I count the dots in my dot plot, I get that this is representing 20 different games. So I have that my n is 20. To find now the mean from a dot plot, you could go ahead and add everything 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2. I'm going to do it a little bit of a quicker way. So if I take a look at my mean, I know that I have 6 ones, so I'm just going to do all of that 6 times 1, just to make it a little quicker. 2 comes up 5 times, so that's going to be 5 times 2. There were 3 games with 3 goals, so that's going to be 3 times 3. There was one game with 4 goal, so that's going to be 1 times 4. 3 games with 5 goals, so plus 3 times 5. And then 1 game with 9 goals, 1 game with 10 goals. It's going to be plus 1 times 9. Plus then 1 times 10. And we can then go ahead and divide all of that by, again, the number of data points that I have, which is 20. So that's then going to get me 6 plus 10 plus 9 plus 4 plus 15 plus 9 plus 10, and I'm going to divide that by 20. By 20. So that gets me an approximate mean, or a mean of 3.15. And now we're going to interpret this in context. So again, the mean is the average. So on average, it's the number of goals that were scored by the women's soccer team in 2016. So interpretation means that we're going to write a sentence. So the interpretation of that number, the average number of goals scored by the 2016 U.S. women's soccer team was 3.15. And that, again, gives the context to what the number is that we just found. Now to find the median. So since I have that even number, I do need to find the middle 2 values. So that's going to be the 10th and the 11th data point. So a dot plot lists everything in order. We just need to count in order to get to the 10th and the 11th. So if I start counting these in order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I get that those are both 2. So 2 plus 2 divided by 2. Again, 4 over 2 is 2. So I have a median value of 2. And again, remember the median is the midpoint or the halfway point. So that means that half of the time the data falls below it, half the time it's above it. So in this context, in half of the games, the 2016 U.S. women's soccer team scored less than 2 goals. And then we can also say they scored more than 2 in half of the games. So just remember, when it says interpret, that means you are, again, giving context about the number and then with the context of the scenario. Okay? All right. Measuring center from shape now. So if we are looking at a distribution, we can tell if the mean or the median is larger based off of the shape. So if I have a roughly symmetric distribution, the mean and the median are going to be similar. If it's skewed, the mean is pulled in the direction of the skewness. So if I look here, a positive skew means that a distribution is skewed right. And a negative skew means that the distribution is skewed left. So when you have a positive skew or a skewed right distribution, I know that my mean is greater than my median. In a symmetric distribution, the mean and the median are approximately the same. They don't have to be exact, but they are going to be very close. And in a skewed left distribution, the mean will be less than the median. All right, so I have a mean test score is 89 and the median score is 77. I want to know what's the shape and then which measure of center best describes it. So since my mean is larger than my median here, I know that I have a skewed right distribution. And again, the reason is because my mean is larger than my median. And then since I have a skewed distribution to describe the center, we would want to use the median. Because remember, the median is always used to describe a skewed. Going to the next one, a diabetic's daily mean glucose reading is 92 and the median glucose reading is 93. What is the shape and which measure of center best describes it? So since I have the mean is 92 and the median is 93, those are very close. So we do say that this is an approximately symmetric distribution because they are very, very close to each other. Mean is about the median. And since I have a symmetric distribution, that is when we are going to use our mean to describe the center of the distribution. Okay, so last one. So I have a back-to-back stem plot comparing 19 middle school students' resting pulse rates and their pulse rates 5 minutes after running. So we want to compare the mean and median and then interpret these in context. So if I want to start with my resting distribution, again, to find my mean, I need to add up all of my data points. So I have this back-to-back stem plot. So my first data point is that 68, and then I have 68 again, 68, 69, 70, 71, 71. Remember, just this how you read the stem plot. So that gets me, when I add everything up, 1,543. And I'm going to go ahead and divide that by 19. So that gets me approximately 81.21. Okay. Throw in the context on there. Again, that's saying the average resting heart rate is 81, or resting pulse rate is 81.21. And now if I want to go ahead and find that median of my resting distribution, I know that I have 19 data values. So if I think about how I split in the middle, the 10th data point is going to be my middle. So if I go ahead and start crossing off, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there is my resting pulse rate. That is my median. So that is 76. Okay. And again, the median, the interpretation, half fall below, half is above. So we can say half the students have a resting pulse rate less than 76. And then half of the students have a greater. I'm just going to put RPR for resting pulse rate. And we can do the exact same thing now to find the pulse rates after exercise. So to find my mean, again, I'm going to add everything up. So 86 plus 87 plus 88 plus 88 plus 90 plus 92 plus 92 plus 94 plus 95 plus 98 plus 99 plus 99 plus 100 plus 104 plus 104 plus 118 plus 124 plus 124 plus 146. So when you add that up, you get 1,928. I'm going to divide that by my 19. So that gets me a mean of about 101.47. So interpreting that, on average, the running pulse rate is 101.47. And to find that median, I again want to find the 10th data point because that's in the middle of 19. So going in order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Gets me a median of 98. So we can say half of the students have a running pulse rate less than 98. And then half the students have a greater running pulse rate. And then if I want to go ahead and compare them, we can see that both the mean and median are larger after the students have exercised for 5 minutes. So that would be a good, that's the comparison. So we can just say both.